All right, so we are going to talk about ionic bonding. This is a review for the test. Our objectives today: explain how ions form, 2, determine the binary or 2 ionic compound chemical formula or name from the given ions or metal or nonmetal. Recognize ionic compounds based on their properties. So an ion, an atom that has either lost or gained electrons, hence it is a particle with a charge. A cation, a positively charged ion, an anion, a negatively charged ion. Here's an example of a sodium metal transferring an electron or losing an electron. The sodium ion now has a full outer shell. It's lost a shell. Sodium is in group 1, so it has one valence electron. So it is more stable in this form, even though it is a particle with an ion, a positive charge. Let's take a look at this video.
In today's video, we're going to explore how ions are made, and why some atoms are more likely to form ions than others. An ion is just a charged particle, so it could be a single atom, like Na+, or a group of atoms, such as a hydroxide ion, which is OH-. As we've seen in our video on electron structure, ions are formed when atoms gain or lose electrons. And they do this in order to have a full outer shell, so that they're more stable. Now, one of the interesting things about the periodic table is that the group number tells us how many electrons the atoms of that group have in their outermost shell. So group 1 elements have 1 electron in their outermost shell, group 2 elements have 2, and so on. In order to become stable though, atoms need to lose or gain electrons until their outermost shell is full. But losing and gaining electrons requires energy. So the atoms who only have to lose or gain 1 or 2 electrons are much more likely to do so and form ions, because it requires less energy. For example, group 1 elements, which we call the alkali metals, only have to lose 1 electron to have a full outer shell, which doesn't require very much energy. So they easily lose that electron to become 1+ ions. Similarly, group 2 elements can easily lose 2 electrons to become 2+ ions. And the same goes for group 6, which gains 2 electrons to become a 2- ion, and group 7, which has to gain 1 electron. However, the elements in groups 3, 4, and 5 would have to lose or gain 3 or 4 electrons, which would require loads of energy. And so this doesn't happen very often, and we generally don't see these elements as ions. Just like we can write chemical equations between different atoms, we can also write equations to show the gain or loss of electrons. For example, in the case of sodium, we could write that a sodium atom goes to form a sodium ion plus an electron. Or let's say we were looking at chlorine. We could write that chlorine plus an electron forms a 1- chloride ion. So as you can see, if the atom is becoming a positive ion and losing electrons, then we place the electron on the right of the reaction. While if the atom is gaining electrons, we place the electron on the left to show that it's combining with the atom. Sometimes atoms will lose or gain multiple electrons though. So for atoms like magnesium in group 2, they'll form a 2+ ion and 2 electrons. So we would write Mg goes to form Mg2+ plus 2 electrons. Or for an example of a group 6 element, we could take oxygen and write that oxygen plus 2 electrons goes to form an oxygen 2- ion. Anyway, that's everything for now. If this helped you out at all, then please do give us a like, and we'll see you next time.
All right, Ions are formed when neutral atoms gain or lose electrons to achieve stability or to have 8 valence electrons. Metals lose their electrons, nonmetals gain. How many electrons are lost by a group 1A once they react with nonmetals? So group 1A will lose 1 electron. Remember, metals lose, nonmetals gain. What will be the charge on a nonmetal that gains 3 electrons? Remember, adding electrons will make it be a negative charge. So we'll have a -3 charge. How do ions form? Right, since ions are not sharing, because that's covalent bond, doesn't share inner electrons. By transferring nucleus? Nope. It's by losing or gaining electrons. So formation of an ionic compound. A nonmetal atom, due to its high electronegativity and electron affinity, which basically says ability to pull electrons off of another atom, pulls the valence electrons of a metal atom, resulting in the metal becoming a cation. Remember, it becomes positive, and a nonmetal atom an anion. The two ions attract each other due to the electrostatic force.
When a piece of sodium metal is added to a flask of chlorine gas, a vigorous reaction takes place that releases a lot of energy, and sodium chloride, a common table salt, forms. The chemical details of sodium chloride formation are similar to the formation of many other simple ionic compounds. Let's view the process of ionic compound formation on the atomic scale. Many chemical reactions occur through a series of steps. In the process of ionic compound formation, the key step is electron transfer from the metal to nonmetal to form oppositely charged ions. As a chlorine molecule approaches the sodium surface, yet before it makes contact, electron transfer occurs. Then a series of rapid steps, too complex to detail here, forms free chloride ions that are attracted to sodium ions and energy is released. Let's isolate the key step and examine a simplified version of it. Electron transfer from a metal atom to a non-metal atom. The sodium atom has 11 protons and 12 neutrons in its nucleus and 11 electrons around the nucleus. The chlorine atom has 17 protons and 18 neutrons in its nucleus and 17 electrons surround it. The sodium atom transfers an electron to the chlorine atom, and the ions attract each other and release energy. The loss of the electron converts the sodium atom into a smaller, positively charged sodium ion, Na+, while the gain of the electron converts the chlorine atom into a larger, negatively charged chloride ion, Cl-. Let's view this essential step once more. Electron transfer and ion attraction occurs countless other times between the sodium and chlorine. The large quantities of energy released vaporize tiny clusters of ions, and these attract others and release more energy. The clusters eventually aggregate and coat the walls of the flask. And even though table salt is not obtained this way, the product of this reaction consists of the same regular array of ions that makes up any sample of crystalline sodium chloride.
All right. What is the ionic compound that is formed from calcium atom that loses 2 electrons and the chlorine atoms that needs 1? Okay, so when we talk about this, we look at calcium 2 plus and chlorine 1 minus. We use these numbers without the positive or negative charge, and we cross them to become the subscript. So this becomes Ca. We don't need to use the 1. Cl2. Calcium chloride, CaCl2. Writing the chemical formula of a binary. Binary means 2 compound, the two element compound. Write the symbol of the metal and its charge, followed by the symbol of the nonmetal and its charge. What is the symbol and charge of aluminum? Remember, aluminums lose electrons, so the only apparent charge on these is the aluminum 3 plus. This is metals do not gain electrons. This shows gain electrons. So aluminum is located in the group 3A. Thus, it is capable of losing 3 electrons. After losing 3 electrons, it's no longer an atom, but an ion with a chemical symbol, aluminum 3 plus. What is the chemical symbol of oxygen after it gains 2 electrons? Remember, gaining 2 electrons is going to make it negative. Adding 2 electrons is going to make it negative 2. This is, if it would gain 6, it doesn't, because remember, oxygen is in the group 16, which wants to get 2 more to make it an 8 or an octet. I made a mistake there. Should have been 2 minus. All right. Writing the chemical formula for a binary ionic compound. Make the magnitude of the charge of each ion without the sign become the subscript for the other ion. All right, so let's take a look at this. We have aluminum and oxygen. So we bring this down the 3 to the subscript of the O and the 2 to the subscript of the aluminum. All right, so let me do that one more time. The 3 goes below the oxygen, and the 2 goes to the aluminum. 2 for aluminum and 3 for the oxygen. Let's make sure I don't misclick here. All right, writing the chemical formula of the binary ionic compound. Step 3, if possible, reduce the subscripts to give the ratio the smallest whole number, so it's reducing a ratio. So looking at this, it says 2 and 2, so a ratio of 2 to 2 copper to 2 oxygen can be reduced as 1 to 1, dividing each by 2. So copper oxide is CuO. Taking into consideration the steps in writing the chemical formula of an ionic compound, what is the ionic compound that can be formed from the following ions? So again, this one, we can take the 2 and put it below or subscript of the chlorine, and the 1 here under the calcium. So we have a CaCl2 compound, ionic compound. All right, so finally, naming the binary ionic compound. State the name of the metal, state the root name of the nonmetal, and add IDE to it. So if I were to take Li for lithium and chlorine, it would be, you'd write the full name lithium for the metal, because the metal is first, and the root name CHLORIDE, chloride. What is the name of K3N? So unlike the covalent bonded, because this is a metal nonmetal, we don't have to use the pent, the tri, the di. So this will be called just potassium nitride. The only thing that we have to make sure we look for is the IDE. Right, what is the name of Li2O? Right, so lithium goes first. It's not this one because there's no IDE on it. It's not this because they're switched around. It's got to be lithium first. And so we have lithium oxide. All right. So I misclicked once on here, so your score should be better when you do this yourself. Good luck.